Continuing 8.2 with ellipses, looking at some examples for this section. Example number 1, given an ellipse with foci at plus or minus 2, 0 and vertices at plus or minus 5, 0, find the standard form of the equation. One thing that I'm going to recommend to you in your homework, as always, just with our triangles, when in doubt, draw out a picture if you're not exactly sure where to start with this ellipse. Since they gave us a couple coordinates, might be a good idea for us to plot where those coordinates are going to be. So I'm just going to draw a quick x-axis and y-axis here, and then we'll plot them. And so as I plot my points here, plus or minus 2, 0, so that means I'm at positive 2, 0 for one of my coordinates and negative 2, 0 back here. And then we'll also have the vertices plus or minus 5, 0. So now we're over here at 5, 0 and negative 5, 0. Now they're only giving us 2 of the vertices. I always like to list all 4 vertices, both the major axis vertices and the minor axis vertices. Oftentimes your textbook, when they give you the final answer, is only going to list the major axis, but when you submit your homework, I do want you to list all 4 vertices of the equation. So in an example like this, they might not need to give us all 4, but just keep that in mind as you go through the homework, that I'm always looking for you to list both the major and the minor axis vertices. Now it's asking us to write the standard form of the equation. So they're giving us some information and then asking us to write the equation. Well, in this ellipse, a couple of things that we know. First of all, here's our focus points, and remember how the focus points were always on the same axis as the A value, and that was always the major axis. So that's telling us that our major axis is going in this X direction, and so then we could do a little sketch of our ellipse. Tricky for me to draw on here. So in theory, we would have a nice symmetrical ellipse here. And we can tell that the x-axis is the major axis. So remember how we had said the larger number is underneath the axis that is your major axis. So if my x-axis is my major axis, the A value is going to go underneath the x. If the y-axis is the major axis, that A value is going to go underneath the y. Now, what things do I know to write my equation? In order to write my equation, I need to know A and B. I don't think they gave me A and B though, right? The distance from the center to the major axis vertex is A, so by looking at my picture I know that A is equal to 5, but the focus point doesn't tell me the B value I was hoping for. The focus point does tell me the C value, however, so now we know that C is equal to 2. How are we going to go ahead and find out what B is? We had that Pythagorean identity, which was A squared minus B squared equals C squared. So your Pythagorean relationship in your ellipse, A squared minus B squared equals C squared, looks kind of like the Pythagorean theorem. Go ahead and plug in the values that we know. So we're going to go ahead and find the B squared value. That gives me 25 minus B squared equals 4. Looks like B squared is going to be equal to 21. Now remember, they're asking us to write the standard form of equation, so technically I probably don't have to go back and write that B is the square root of 21, because as I'm writing out the equation that you can see here in green, if I'm writing my equation, I'm going to have x squared over A squared is 25, plus y squared over B squared. That B squared value was 21, and we knew that right here. So like I said, you maybe wouldn't need to go back to calculate the square root of 21 or fill that in this case. And then we also know that our ellipse is always, always, always set equal to 1 when we write it in this form. So that's example number 1. Example number 2, now they're giving us the equation and they're asking us to find the major axis, the center, the vertices, and the foci. So just the reverse of what you did in example 1, where they gave you some information and you had to find the equation. Now they're giving us the equation and we have to find all of the stuff. All right, so for the major axis, what I'm looking for is the major axis in the x direction or in the y direction? And in this case, I can see the larger number is right here underneath the y squared. So it's underneath the y. That means the major axis is going in the y-axis direction. So we can just write y-axis. Sometimes people will tell me how long it is. Sometimes people will tell me any number of different attributes about the major axis. But what I'm looking for when I ask this question is it going in the x direction or the y direction? Where is the center? Well, we said so far we were going to start with centers at 0, 0, and you still see this x squared and this y squared here. So we're going to go with a center of 0, 0, and when we get to the next example, you'll see what it looks like when our center is in a different location. All right, vertices and foci are going to be next on our list, and in order to find those, I'm going to need to know the A value, the B value, and the C value. So before I fill those in, let's check out what we know about A, B, and C. We remember that A is the distance from the center to the major axis, and A is the larger number. So I can tell that A squared is 100. Since it's a larger value, that's going to give me A equal to 10. B squared then is the smaller of the two values. That's going to give me B equal to 6. And they didn't tell me C based on the equation, but I certainly can find it. Again, A squared minus B squared equals C squared, and we're working on committing all of these to memory, both the ellipse equation and the definitions of the A, B, and C. So A squared is 100, B squared is 36. That's going to give us a C squared value of 64, or in other words, a C value of 8. And now that we know our A, B's, and C's, we can go ahead and write down the vertices and the foci. Some of you might be able to just write down the answer to the vertices and the foci right now. The one thing that I want to caution you about is that what we want to know, I know that A is 10. Okay, so my question to you is, center at 0, 0, is the vertex point 10, 0 or 0, 10? If you know the answer, you can go ahead and write down the vertices and just move on. But for many of us, it's easy to flip-flop and accidentally write it in the wrong spot. And so what I might recommend to you, like we said, draw a quick little sketch. I can tell that the larger number is underneath the y. Maybe I just draw a quick little ellipse to remind myself. And I'm going to draw one with the y-axis having the major axis. It's longer in that direction. You don't even necessarily need to label the coordinates of the 4 vertices that we're seeing in this diagram, but it should at the very least help you to say, hey, this is longer in the y direction. So when I'm getting to my vertex points, A is the distance from the center to this major axis point, right? So this little distance in here is A. Well, if this is 0, 0 and I'm going up to get to that spot, I can tell that that's going to be at 0, 10. And then also 0, negative 10. Your choice if you want to label it on this picture or just write down the answer. That's 100% up to you, whatever you feel more comfortable with. So the picture is not required, but it helps us to know that I'm going up and down. Another option for you, by the way, when you're writing these out, sometimes people prefer to write this as 0 plus or minus 10 and just write it as one coordinate. So you can do, again, whatever your preference is. If you want to write the blue version, 0, 10, 0, negative 10, or if you want to write it with the plus or the minus, you're welcome to do that as well. So those were our major axis vertices. Let's find the minor axis. Distance to the minor axis, that's the B value, right? A to the major, B to the minor axis, clearly not to scale. B is a distance of 6, so that means we're going to get 6, 0 when I move to the right. That means I'm going to have negative 6, 0 when I go to the left. So again, go ahead and write them out separately or combine them together. That's 100% your choice, whatever you feel more comfortable with here. So if you want to write the plus or minus, or if you want to write them as the individual coordinates, you decide what works best for you. And the last thing for us to write would be the focus points. C is the distance to the focus. That's 8 units. Remember, the focus points are always, always, always on that major axis. So C is the distance from the center to this focus point right here, going up and down 8. That's going to bring you to 0, 8, and 0, negative 8. Feel free to do the plus or minus if you choose for that one. All right, next thing that we're going to look at is if our ellipse has a different center. So in your textbook, they show you a picture with the ellipse at HK, HK representing wherever we choose that center to be. It looks a little more complicated in this diagram than what it really needs to be. So we're not going to memorize this in any way. We're still going to keep our same definitions of A, B, and C as we change the center of the ellipse. So just in looking at it in a more general sense here, if we have HK, what I want you to notice is that the distance from the center to this vertex point is still A. Notice how they added A to the H value. We moved A to the right, and the K value stays exactly the same. Notice to get to the focus points, we add and subtract the C value to get to those points. So it's still adding and subtracting the A, the B, and the C. It's just a matter of where our starting point is. So let's show that in an example. So example 3, find the major axis, center, vertices, and foci for this ellipse. Major axis, again, I'm really just looking for you to tell me, is this going in the x-axis direction or in the y-axis direction, the bigger number underneath the x? So that's going to give me the x-axis for the direction of that. Again, this isn't exactly on the x-axis because now you're going to see that your center is not at 0, 0 anymore. Pretend like this was a circle. Where would that center be? Looks like the center of that would be at -3, +4. So just like the center of the circle changes, the center of the ellipse can also change in that same manner. Now, just like our previous example, in order to find the vertices and the foci, we probably are going to want to look at the A, B, and C values. And we also likely will want to draw a sketch to make sure that we're remembering where everything is going to go. Okay, so when I look at this bigger number underneath the x, that means my ellipse is going in the x direction. And once I draw my ellipse in there, I'm going to draw my x and my y axis. Oofty. Not so straight, but we can go with it here. And once we draw our ellipse, so I have my ellipse, I know the center is at -3, 4. Notice that I'm drawing in the major and the minor axis. I'm not drawing this as a coordinate grid with an x and a y and then worrying about how far that I'm shifting that over. So I just draw my ellipse and I plot the center. Don't worry about having an entire coordinate grid and where that's going to go. As I pick out the values here, it looks like my A value is going to be 10, right, from the square root of that 100. My B value is going to be 8, and then we're going to need to figure out that C value. We'll use that Pythagorean relationship to do that. A squared minus B squared equals C squared, so you've got 100 minus 64. C squared is going to be equal to 36. That makes your C value equal to 6. So we have all of the A, B, and C values we need. And now we're just going to make sure that our vertices and foci end up in the right spot. So let's get to doing that part. Again, x-axis is my major axis, or the horizontal, I should say. The horizontal line here is my major axis in the x-axis direction here. A is 10. That means I'm going 10 to the right and 10 to the left to get to these green dots that we have here. If I move over 10 units to the right, where am I ending up here? So -3 is my x value. I'm not going up or down, I'm just going to the right, so it's only changing my x. That's going to make this point here at 7, 4 if I add 10 to this x value. Now go back 10 to get to the other green dot here. If I go back 10, that's going to put me at -13, 4. Again, I haven't changed the y value, haven't gone up or down, so those points will stay right there. So here's my vertices, -13, 4, and 7, 4. Now those are just the major axis vertices, so we do want to find the minor as well. I'm going to put those in orange right here. So we're going to find the minor axis vertices. To those, that's a distance of 8 for the B value. So now I'm going up 8 and down 8 from the center. That means my x value is not going to change, right? My x value will stay the same. I'm just going up and down, so that's only changing my y value. The center was at negative 3, 4, so if I go up 8, that puts me up to 12. If I go down 8, that puts me at negative 4. So it looks like we have negative 3, 12, and negative 3, negative 4 for the minor axis vertices. And finally, we're going to list the foci. To get to the foci, again, those are always on the major axis. Distance of C takes you to the focus point, so from the center, go 6 to the right, 6 to the left, add 6 to this x value is going to give me positive 3 and a 4. Subtract 6 from that x value, that's going to give me negative 9 and a 4. So we'll list those negative 9 and 4 and 3, 4 for my focus points. All right, and example number 4, find the major axis, center, vertices, and foci of the ellipse with this equation. The main difference we're seeing here is that it doesn't look like our ellipse equation did so far, does it? Now we have this in our form where we're going to have to complete the square to figure out where the major axis, center, vertices, and foci are with this equation. So in completing the square, similar to how we did with the circle, we need to put all the x's together and all the y's together and move that constant over to the other side. So that's what we're going to start with. 4x squared minus 8x. And then I'm going to group the y's. We've got the 9y squared and the 54y. Take out my subtraction here. Minus 54y. And then move that constant over to the other side because we don't need that. Remember that we were wanting the leading coefficient to be a 1, and that means out of the x's, we're going to have to factor out a 4. Out of the y's, we're going to have to factor out a 9. So I'm going to take out that 4. That gives me x squared minus 2x. Remember, I'm going to leave a little space because I know I need to add something in my completing of the square. I'm going to factor out a 9 as well, a y squared minus a 6y. Again, leave a little space because I know I'm going to need to add something there. So that's my first step. Again, I strongly recommend leaving that space so you can figure out what you're adding. Don't write them too cramped together or it makes it hard to rewrite those there. Then we'll complete the square. So the 4 is out front. Remember, we take half of that middle number. So we've got x minus 1. Square, that means I add 1 here, but remember, since I factored the 4 out, that means I'm really adding 4 to this side. We'll do the same thing for the y's. We've got the 9, y minus 3. When we do half of that y value, square, it means I'm adding 9, but again, because I factored out that 9, I'm really adding 81 over to this side. So that gives me a grand total on the right hand side for a constant that's 36. Oops, and I forgot my square up here. Okay, almost there for writing our standard form of this ellipse. We know that the final version needs to be set equal to 1, so in order to accomplish that, we need to divide everything by 36. So dividing every single term by 36 here, that's going to give you a 1 on the right hand side. Now these fractions looks like I'm going to have x minus 1 squared over 9 plus y minus 3 squared over 4 equals 1. So now that's in a standard form where I could more easily pick out the major axis, the center, the vertices, and the foci of the ellipse in that equation. Why don't you pause the video right here and you can on your own calculate what those values are, and then once you're done, check back and we will show you those answers. All right, and here you can see our major axis in the x-axis direction, center at 1, 3, and vertices and foci listed there. One last thing for us to look at is just a comparison between what we know about ellipses and circles now that we have looked at both of them. So we know that when we write the standard form of the ellipse, what you see here on the top, x plus 1 squared over 16, y minus 2 squared over 4 equals 1. We would want you to be able to look at that equation and say, hey, that's an ellipse, that's the standard form that I'm looking for. On the top, on the right-hand side with the circles, again, you can look at that one and say, hey, that's a circle. You can tell the center is at negative 3, 0 with the radius of 4. Now, everything on the left-hand side is an ellipse. everything on the right-hand side is a circle. So just a couple differences that we want you to look at. In the left-hand side here, 36y squared plus 4x squared equals 144. Sometimes people will think that looks a little more like a circle than an ellipse, but what I want you to notice is that these leading coefficients are not the same, and that's what makes this an ellipse instead of a circle. If I would set this equal to 1 and divide every single term by 144, then we would get it back to a form that looks like what you see on the top. Likewise, the second equation on the circle side, this kind of looks more like an ellipse right now. But when I actually take a closer look at it, I see that both of the a squared and the b squared values are the same. Well, we know that if a and b are the same, it actually makes a circle instead. And so in this one, instead of leaving it in the way that it's written, we would multiply everything by 16, and that would create an equation that would look more like a circle. X plus 1 squared plus y minus 2 squared equals 16. So we just see things that look similar to ellipse, but because those denominators are the same, we know that we actually have a circle there. And then finally, when you look at the equation when we haven't done completing the square, we mentioned it in this example up above as well, but look at just the squared values. 2x squared, 4y squared. If those leading coefficients of the x squared and y squared terms are different, I know that it's going to be an ellipse. If those coefficients are the same, I know that it's going to be a circle. So that's going to be one of your telltale signs as you're going through to say this is a circle or this is an ellipse. And now you guys can take a look at your homework in your textbook that's posted for you to work on. Good luck!